So for conduits and downtown underground kind of management, right? So this is AUD, right? Um, so this is a view of conduits and conductors routed in a downtown underground type situation. These are details. So if you haven't worked with details or you're not using details in your implementation, ask your project team about them, ask your advisor, your partner about them. Details are our way of saying you don't have to be in 3D to work with 3D, right? So I'll back up here a little bit and show you what this looks like in 3D. This is our test drawing. So this is what Dave kind of runs through. Let me see if I can get my mouse configured here. This is what Dave kind of runs through when he's doing some dev on 3D conduits and segments. And you can see the green is the segment up at the top splitting in 50 million different directions. And there's ports and conduits all over the place so that we can test connectivity. But these details are actually showing that in this segment, this is what's in that trench. And these are interactive with the 3D, right? So if you do a detail on a vault and you shift what port it's in, it will actually shift it in the 3D. So we wanted to make something where people don't have to be in 3D to work in 3D and really get the advantage of, all the 3D cable pulling and calculations and things like that. This is one of our recommendations is to look at details and to make allow your users to see what's in trenches without having to go into 3D or be afraid of the 3D side of the world. This one is one that I like to show. I showed last year as well. This one is just a simple overhead extension with a transformer at the end and some services coming off of it. But the interesting part and the part I want to point out is that I have some miscellaneous pads that I like to place. And one of them is a house, and one of them is a tree. And those are not electric, gas, water, or communications, right? AUD is a platform. If you want to draw in 3D, you draw in 3D. If you want to draw in 2D, you draw in 2D. If you want to draw trees, if you want to draw houses, you want to draw gas, electric, water, AUD needs to know what you want to place, what the block is, and do you want to have any materials with it, right? So think outside the box when you're doing some of your implementations. Maybe your users need a pool to place to show on a drawing on a construction print to make it easier for your construction people. Maybe they need some trees in order to call for some sort of tree clipping or tree removal when they're doing it. But AUD will support you in that. Switch over to 3D so you can see that side of it. Anybody ever have this situation and want to know the closest distance between a conductor and a leaf on a tree? AUD will calculate that. It's called AUD clear dist, right? And it will calculate vertical, horizontal, and check your clearance distances between any 3D object. So think outside the box. Think of what your designers need, what will make their life easier. Don't go and make gingerbread stuff just for the sake of making gingerbread stuff like I did, but actual usage. Like this is a use case for a lot of people that we have a lot of heavily treed areas and we need to check clearance distances to individual trees. There's a lot you can do in that space with AUD. Yeah.
Are the trees based off of measurements that the designers are taking in the field, like those distances, and then they're importing it? Or is that just a best guess based off the average tree size in the area?
Yeah, so this one is just one that I made up as a demo scenario, right? So it's just an individually sized tree. There is no reason you can't have a small, medium, large. There's no reason you can't have a dynamic block. A lot of the substation folks, the P4A folks, are actually making dynamic pads and dynamic foundations, and there's no reason you couldn't have a dynamic tree with a different circumference or different radius, that sort of thing. All of the CAD functions, right? AUD builds on CAD. So all of the CAD functions are still there. All the block support is still there. What does your process need? It always comes down to what does your process need? And like John pointed out earlier, it's configurable. It's configurable. Was that like 3 of the it's configurable? You look at what your process needs, what can save us time, what can help our designers, and then you configure that in. So maybe in your area it's best to only have one tree. Maybe in your area it's best to have a dynamic tree. I don't know. It depends on your situation.
Oh. To piggyback off of that question was, would a LiDAR data set be a suitable replacement for that in that regards, for doing that same check?
Yeah, so LiDAR is a big thing on the substation side, and it's starting to move into the distribution side. We're seeing more and more people on the distribution, and SBS folks around, Sergey in particular, I think you've been working with this. Chime in if I'm going way off crazy base. So LiDAR requires some processing, right? Like Map has tools to actually cut chunks out of LiDAR. And once you define that chunk, you can turn it into a block. Okay. So in order to do some of these processing at this point in time, you have to have some sort of defined chunk of something. And so the way we've done it just in playing around is to actually carve out that piece of it and turn it into a block, in which case then we can do some clearance stuff on it. See a situation where you could pick a point on the LiDAR and ask it, like, what's the distance to this thing? Because our clearance distance requires you to pick two things. So if you could pick a point on it and say, what's the distance to this? I could see that working. But if you're just generally have a LiDAR cloud and say, find the pole in there, that's not ready for right now. You had a question.
Yeah, so we have a couple of our designers that work in MicroStation predominantly, and they've created libraries with things like this, trucks and trees and houses
Yeah.
and stuff. Would that be able to be imported in potentially? Is that an easy process? Have you seen it be done?
For sure. Yeah. So the question, about MicroStation AutoCAD interoperability, basically, MicroStation operates off of cells, which are the equivalent of blocks, right? And for a long time, AutoCAD and MicroStation kind of butted heads about things, but then about 10 years ago now, they cross-licensed each other's engines, and they allow an easier transfer back and forth at that level. So you can just take your cells and kind of open them up and turn them into blocks fairly easily. That's probably the best approach, would be to turn them into a block, and then you could use them in the AutoCAD environment or infrastructure. Yeah, when you're converting entire drawings, there's some tricks, and they're well documented out on the web. But if you're just doing individual cells to blocks, it's usually okay. I think there's even a command to convert a full library over, to be honest with you. Just to show that AUD is P4A. P4A is AUD. This is the exact same software. Everybody recognize this stuff? Look a little familiar? It's the exact same AUD software designing full-on 3D, every component, every connector down to the nuts and bolts, and full-on 3D snapping together like Lego blocks, just like your 2D does. We're doing this because there was a need on the substation side. We've obviously had a substation product for a while, but we really believe that there's more and more need for 3D on the distribution side. The need to be able to do correct element analysis and attachment points and calculations. And so we've really taken advantage of being able to dual purpose this development. When Dave said on his presentation yesterday that, P4A is AUD and you're getting benefit from this, even though it's not really a 3D world in distribution yet, the product supports it. It gives you that much more room to grow and more to think about as you get into that, because we don't know where the requirements are going to come from next on the government legislations and regulations. There's talks about changing the way poles, under 60 feet right now are exempted from certain analysis and structural loading, but they may not be in the near future, and that's going to blow everybody's mind in the utility world. We're trying to prepare for this world where 3D is more of a necessity than a nicety, which it is right now. So all of this stuff that we're trying and we're playing with and we're trying to figure out in 3D, it's more than just, our substation customers really wanted it and it's helpful to them. It's also trying to plan ahead for you guys for the future.
Do you ever see AUD going to more of an actual connectivity, point-to-point connectivity, kind of like the GIS world? Do you see that ever going to that? I know that we're big on our connectivity model, and so we actually have like physical connectivity instead of like segment connectivity.
AUD supports a lot of different types of connectivity, and we're continuously looking at that as well, right? So some of the stuff that you saw with the physical connectivity yesterday that Dave was doing is just expanding our ability to interact with and understand how things relate to each other. This one in particular, I mean, when you start talking about connectivity, there's all kind of point and edge models and point-to-point models, and point-to-point can mean, is it two devices or is it, a conductor to a, there's a lot of terminology differences depending on what GIS you're coming from, what world you're in. I would say that in general, AUD supports a wide variety of connectivity. What you're seeing on the screen, I can literally tell you that it starts with this connector, goes to this conductor, sags to this step, goes to this connector, which is on a connector, which is on a connector, which is on an insulator, that goes to a structure, that goes to a pad. Like, I know every single piece of what's going on in that substation. We can support to that level, or you can support to, I have a circle that has a triangle that goes to a straight line to another circle. It's all AUD, right? And it's all connected and attributed and modeled, and you take it from one end of the spectrum to the other, you take it where your process needs you to go, right? Does that help? I didn't directly answer because we can talk terminology later, but in general, I think we got you covered. But
you may have a transformer with elbows and attachment points, all separate elements. So utility data hub for GIS can help to basically take that complexity of GIS created in a simple world of AUD to complete your construction drafting. But when we report back to GIS, we do this magic transformation of from one transformer, create all elbows and assign them, connect them properly to respective conductors, maintaining all the concepts and connectivity details from design to GIS. So it's kind of dual world. Yeah.
yeah, it's not always perfect, right? I mean, I'm sure if I surveyed everyone here that their GIS data is 100% perfect and there's no data variations. So of course we can 100%, no variations, put that back. That's not the case, right? There's always data variations. What we don't want you to do is have to manually enter a bunch of things all the time. So we'll get the data over there and we'll be able to put it in many cases. In other cases, there will be cleanup. The data doesn't match the way that it's supposed to match in the GIS or what we can promise you is that you won't have to type in attributes, right? We'll get those over from design. We'll get you to the right location. We'll be able to insert most of them. But when you get to like connecting it to something else, maybe somebody did something to that. You might have to fix that, right?
I just wanted to interject a comment too,
Yeah.
because yesterday I was talking, is this on? So yesterday I was talking a little bit about AUD for telecommunications. So Sergey, Jim, and others have been doing quite a bit of interesting work in that area too. That's an area where we don't feel it's appropriate for us to use AUD down at a fiber strand level. There are other tools that do that. So we've kind of advanced to interoperability with utility network on that level. So we want to do sensible things that support design operations, but we don't want to take it, to a level where we're doing too much in the product, because then that's going to cause the product to collapse under the weight of all the complexity we've added to. So we do have some solutions that we're working on in that area, and I think we saw it with John's presentation. We see it with all of you. You have fiber networks out there too. You're doing quite a bit in communications. So that again, I think would be a really interesting topic if you want to bring that up to Sergey or Jim tomorrow during those open sessions, because we're doing some really, really interesting things there that we don't think anybody else has quite sorted out yet. So.